All right, everyone. So we will continue with this SHP module on lecture number 4. So this is still on acceptance sampling plan. Okay, part 2. Yes. Okay, so we'll take a look at some of the terms that people use in sampling, population versus sample, some sampling techniques, single, double, multiple, and how people change their sampling plan. And then we take a look at the acceptance sampling plan again and the OC curve. Okay, this one is the most difficult part of this lecture. Okay, let's quickly go through things that should have been covered already. Okay, so when you talk about the lot, usually in sampling plan terms, they call it population. That means the whole area that you're taking the sample from. For example, if I take maybe again Bedok Reservoir water from Bedok Reservoir, right? The reservoir, the Bedok Reservoir is the lot. That means the whole population. Whereas the sample is the small part that you take from the population. In this case, the sample is your water sample, and your population is the water in the Bedok Reservoir itself. Okay, so this is what sampling is all about. So you have this whole square here with all the yellow circle inside, right? This is all the whole population. So then you take a sample. Okay, that means you only take a certain portion, right? Because your sample is the subset or the smaller quantity of the whole population. Take it out, and there's your sample. Okay, so the population is all this. Sample is the small part that you take it from. Remember, these terms. And then we covered lecture 2, I think, simple random sampling, right? So this randomly pick some of these yellow circles in this population here, and then that's your sample, and must be random, okay? Cannot be selective. Okay, so you just take it. Same thing here, random, still on random sampling. So you have all these palette, right, with all the boxes on the palette. So to make life easier, they numbered all the boxes in that palette there. So you have all the numbers, so they can use a random number generator or picker to pick the numbers randomly, and then those number that is picked, they go there and take out the boxes that is according to that number lah. Okay, then that is your sample to be brought to the lab to test. Okay, so this is random. Everything is randomly selected. And then you have stratified. This is still considered random. That's why there's stratified random sampling, except that you divide the boxes or you divide into groups. Like for this case, right, there's no division. You just randomly pick, right? Here, for example, you have a distinct groups. So in this case, given here, it is male and female. So it's two distinct groups. So they divide into these two groups first. Okay. So when the population, the whole thing here, consists of a mixture of more than one element, that means very distinct groups. That means you can change, divide into male and female, for example. Whereas these boxes here, you cannot. Okay. So for in this case, you can divide them into group first, and then what you do is after you divide them into groups, you select a sample from each group. So you select from the male group randomly, you select from the female group randomly. Okay. Please take note that the size, how many sample you take will depend on the size of the group. For example, here, right, you see more guys there, right? Okay, more males here. So you take 4 samples. Whereas the females, there's less. So you take lesser sample, only 2 as your random sample. So it also depends on the size of the group. So this is stratified. Whereas for systematic, it's just you decide first after every how many product you take out as a sample. So in this case, every third item is selected as your sample. So in your population, right? So every third item in your population is taken out, and this will then contribute towards your samples. Okay, 3, 6, 9, every third. So you have to decide lah whether every third, every fifth, every 10, okay, before you start taking your samples. Cluster sampling is different. Remember just now those boxes, there's no group, right? So what they do is they divide into different cluster first. For example, maybe the top group here, and then the second level as one group, the third level as another group, fourth level another group, for example. Then you take randomly from each of the groups. That means the top layer you take one or two sample, then second layer you take one or two, something like that. So you divide them into clusters first, because there's no distinct group to do stratified sampling, right? So just divide them into clusters lah. Then you randomly pick from each cluster. Okay, next one, single sampling procedure. That means you take your samples one time, not one sample, but can be more than one sample, 5, 10 sample, but one time. That's the difference. Okay, it's the most common, obviously, and the easiest because you only take your samples only one time. And then after that, you take your sample, you test, and then you calculate how many defects are there in that sample group that you test. And then you decide lah whether it meets your specification. Acceptance number. Acceptance number means that how many defects you can tolerate. That means if my acceptance number is 5, it means that I can accept up to 5 rejects. Got it? Okay, this is called acceptance number. So if my acceptance number is 10, I can accept up to 10 rejects in my sample. Okay, so therefore, if my defective item is less than my acceptance number, I accept the lot. Okay, so if it's 10, anything 10 and less, I accept lah. Okay, so that's the meaning of acceptance number. Yeah, this is just a flow chart. So what you do is you take, so depending if you want to use the military standard like in the previous lecture to decide how much size or how many samples to take, then you can use that table lah. Okay, so randomly select how many samples. So n, small n is the sample size, big N is the population size, the lot size, the whole thing. And then once you select, right, all the items, test all the samples, then you calculate how many defects you find in your sample. And then the number of defect is D. C is your acceptance number. Okay. So let's say my acceptance number, I can accept up to 10 rejects. So anything less than 10, I accept. Okay. Less or equal to. Okay. So anything 10 and less, I accept. So it depends on my acceptance number. And if it's more than that, my acceptance number, which is C, I reject lah. That's all. Then whether you want to accept the whole lot or not is like that, just one time only, based on the sample that you test. Okay, here you can try out using the military standard table to find the acceptance and rejection number. Double means like you take the first time like that, right? Then after that, right, when you calculate the number of defect, you're not really confident whether you should accept or not. Then you take another time. That's called double. Second one. Second time you take a sample and test second time. And please take note, after you test the second round of sample, right, the result you get, you should by right combine with the first result. Okay, don't just keep on testing until you get what you want. It should not be like that. Okay, you should combine it with the first one, first results. So same thing here, select your sample size, inspect the samples that you collected. Okay, check if within your sample number, okay lah, good lah, okay, accept it. If no, got problem, right? So you still want to one more time, so you resample again and do again the second time. Okay, and check again, sample number. If yes, then of course accept. If no, then too bad lah. Okay, give 2 chance, they cannot. All right. Anything more than 2 is not triple already. It's called multiple already. Okay, up to 2 only. There's another one here which is called sequential sampling. Okay, this one you inspect or you test one at a time. Then you decide whether to pass or fail or take resample second time. Okay, one by one. That's called sequential, in sequence. Okay, sampling plan. This sampling plan actually is not fixed one. You can actually change, you can switch. Okay, but I don't know whether you remember I mentioned in the earlier lecture, when you're not sure what kind of product you have, whether it's valuable or not, it's always default start at level 2. Okay, always start level, unless you are told that it should be level 1. That means it's very, very cheap product. If it's not mentioned, always default level 2. But the problem is, somehow or other, when you produce the product, it's not so good. So when you have 5 consecutive lots that you produce, okay, consecutive, that means must be one after the other, okay? Out of these 5, 2 of your lots is rejected. Take note of these lots, this is the population. That means you do everything, take sample, test everything. Okay, so when you reject, you have 2 reject of 5, something is wrong. Okay, so we don't want too many rejects. So what you do is you change from level 2 to level 3. Okay, to tightening special. Why is this so? Firstly, level 3, if you remember, is for more expensive items, right? So you have to treat your process when you produce this product as a level 3. That means it's more expensive. That means when it's more expensive, you tend to be more careful when you produce this product. Okay, so when you tend to be more careful, you do less error and you can produce better products. This is why when you have rejected lots 2 out of 5, you should tighten it and treat it as a more precious product, level 3. So in this case, you produce your product more carefully and so on, okay, so that you have less rejects. That's the whole idea. Okay, so you only go back to your default when the next 5 are okay. That means you accept all the 5 lots. Okay, so same thing like if your product is start from level 1, they may want to treat it as a level 2. Okay, a more expensive option than level 1. And then once everything okay, then you can go back to level 1 again. Right. Okay, this one we already discussed already in the previous lecture. Because you don't test everything, you only test that sample size. So there's always a chance that your good product is rejected and bad products is accepted because you don't test everything. Okay, you only test the sample and not the whole lot. So this risk, as mentioned in the earlier lecture, is always there if you do sampling. Cannot remove it. Okay, this is the problem. So they classify these two as type 1 and type 2 error. What is type 1 error? Incorrectly rejecting a lot that is acceptable. That means you take the sample, you test, lousy, reject the whole lot. But actually, the rest of the lot is good. So this is called type 1. Okay, it's called producer's risk. That means usually the problem or the risk lies with the manufacturer, because if they reject this good lot, who's the one that suffer? The manufacturer. That's why it's always producer's risk. Okay, when they reject the whole lot, they lose money, right? But actually the rest of the product is good. So this is the risk that falls on the producer or manufacturer. So this is about 5% is there. Okay, usually about 5% chance they reject lots that is actually good. Okay, so you cannot remove this risk. It's always there. Okay, so some people express the percentage as a probability. Okay, and produces this lah. Type 2 is the other way around, accepting a lot that is unacceptable. That means I test, it's very good. All my samples I take happen to be very good, but the rest is no good. So this is called type 2 or beta error. Okay, and the name of this risk is called consumer's risk. Why? Because when the company, the manufacturer accept the lot that is bad, that means I accept, right? But actually the rest no good. When they accept means what? They sell to you as the consumer, the user. So who's the one that suffer now? The consumer, you, the user. Okay, because manufacturer say good, but actually the rest no good. Then they sell to you, so you get the bad lots. That's it. Okay, so that's why it's called consumer's risk. So it's about 10%. So double the producer's risk. Okay, So sometimes people call it the RQL, or the probability of having this error. So RQL is beyond AQL. I don't know whether you remember. AQL is called acceptable quality level, the maximum reject they can accept. But this is beyond AQL already. Okay, beyond AQL, because maximum already, right? Beyond that, I don't want to accept anymore. So it's called RQL, rejectable quality level, and sometimes it's called LTPD, lot tolerance percent defective. So this is a level that is unacceptable to the customer, not acceptable. Okay, AQL is the maximum risk I can accept, maximum defects. Beyond that, RQL. Okay, this one is a bit complicated. Okay, don't worry so much. This is called an OC curve. OC stands for operating characteristic curve, and it qualifies this risk. So this graph, right, is the OC curve. It tells you the probability of you accepting a certain amount of defects. So here on the y-axis, on the left side here, you have the probability. That means how much chance for you to accept a rejected product. And the x-axis here is how much defect there are in your lot. Okay, so as you go further down on the right, there's more and more defects. So obviously, the more defect you have, the lower chance of you to accept that lot. But then there's still a chance. Okay, of course, when you have no defect, you definitely accept one or 100%. Okay, this is the probability. So that means 1 is 100%, 0.8 is 80%, and so on. So by studying this OC curve, the manufacturer can actually see, okay, what are the chance that they will accept a certain amount of defects in their lot. So how to find out the probability is very simple. You just extrapolate. For example, the first one here, lot quality defect is 0.093. So you just extrapolate up, touch the graph, and then extrapolate to the left to get your probability, which is 0.05 plus minus, or 5%. Okay, if it's 0.018, you just extrapolate up, touch the curve, move to the left to get your probability, which is about 0.95. Yeah, this is how you find the probability based on the OC curve. Okay. So here what it's saying is that if you have a 90% chance of accepting the lot, right? So what is the other way around? Is 10% you will reject the lot, because 90% you will accept, right? Therefore, the percent of chance of you rejecting the lot will be 10%. Okay. This is ideal OC curve, which is impossible. But if it's ideal OC curve, then it's either you 100% accept, or got defect only, you straight away 0%, no chance for you to accept. But there's no such thing lah. Okay, this is the ideal OC curve. So it's either 100 or 0%. That's it. Okay, but real life, of course, you know, right? There's always a chance. So this is the one. And then among the OC curve, there's type A. This one is for small size, type A. Type B is big, very huge lot. Your population is very big, right? So that's not much difference actually, but slightly different. Okay, this curve, right? There's many shape and sizes. It can be lower gradient, it can be more steep, it can be less steep, and so on. So what causes the OC curve to have that particular shape? Two things: acceptance number, sample size. Okay, how much sample you test, and what's your acceptance number? I don't know. Again, remember just now, acceptance number means the maximum number of rejects or defects you can accept. So you have 10 as a acceptance number, I can accept up to 10 defects. Okay, that is the two factors that affect your curve of the OC curve. Decreasing acceptance number is preferred over increasing. Okay, this one we will take a look in the graph later. Okay. Okay, let's take a look at this graph. So you have the green one here, which is a sharper gradient. Okay, and then the black one here, which not so sharp lah, the curve. Okay, so what causes this to be sharper and this to be less sharp? Just now we mentioned, right, acceptance number and sample size, right? Sorry, okay, so the more sample you have, sample size increase, the more steep is the curve. Okay, steeper the curve, the more discriminating between good and bad lots. What does this mean? So if you were to extrapolate, let's say 3, okay, 30% of defects in my product, the lot. So you extrapolate, right? There's one with the steeper curve will have about 20% chance. Whereas the one that is less steep, let's say the black one here, if you extrapolate, right, you have about 40% chance to accept. Which one is better? You don't want to accept the rejects, right? So lower probability is better. Okay, so therefore, steeper the curve, the better it is. That means less chance of you accepting a defective lot. Okay, so the steeper the curve, I repeat, the steeper the curve, the less chance of you accepting a rejected product in the lot. This is the meaning of this. The steeper the curve, you can actually distinguish better between the good and bad product. That means you know better. Therefore, if it's a lot of bad products, I can reject the lot. That's why I have a lower chance to accept a rejected lot compared to a less steep here. My gradient is less steep, so if I extrapolate, right, actually it's higher, even though the amount of defect is the same. Okay, so people will prefer a steeper curve lah, because you can actually have a lower chance to accept all the lousy products lah. Okay, that's the meaning of this. Okay, higher sample size, higher the chance of rejecting products. Okay, all right. Next one, acceptance number. So remember, we already say two factors, right? One is sample size, one is acceptance number. So acceptance number is how much reject you can tolerate. So if my acceptance number is very small, it means that I'm very strict. That means, let's say I have acceptance number of 10, acceptance number of 1. So 1 means I can only accept 1 reject. 10 means I accept 10 reject. So 1 is more strict because I can only accept up to 1 reject only. A very strict one. Okay, so this means that therefore my graph for a lower acceptance number will become more steep. Because if I'm very strict, I will definitely know better whether to accept or reject the lot. So I can actually have lower chance to accept the rejects already because I'm very strict. Okay, so I don't accept a lot of reject one. Therefore, my probability of accepting the lousy lot also will be lower. Okay, because if I'm more relaxed, right, I have can accept the number very high. I'm more relaxed. Never mind, a lot of reject also can. So definitely lah, you have a higher chance of accepting that rejected product. Okay, so these are two factors. Increase sample size, reduce acceptance number. Lower acceptance number means the graph will be steeper and you have lower chance to accept a rejected product. Okay, so these two is the best. Okay, but please take note out of these two, higher sample size, lower acceptance number. The better one is still lower your acceptance number. That means be more strict compared to increase your sample size. Because why? The higher your sample size, the more you have to spend money to do the testing, right? You have more sample, you have to test more. When you test more, you have to spend more. Testing is not free. Okay, you have to spend more. So that's why it's best to be more strict, lower your rejects acceptance. Then it'll be better for you compared to increasing your sample size. But still okay. If you want, you can test more. So both will affect. Here you can see better. Okay, so let's say I have the same amount of reject, right? About 0.045. So curve B more steep, right? If you extrapolate, you can see here curve B, because it's more steep, has a lower chance, 10%, about there lah, 10% chance, 0.1, right, of accepting, whereas curve A less steep, 40% chance. Okay, so that's the reason why people prefer a steeper curve, okay, or an increase the sample size or be more strict. All right, so that's it for this lecture. Again, if you have questions about this, especially the OC curve, please feel free to ask us when you see us. All right, thank you.